Hi, question number 10. A long jump athlete take off at 25 degree angle horizontal and achieve the jumping distance 9.12 meters. So calculate initial takeoff speed. So if you draw the situation given by the question, let's say you have this is, let's say, the object. I look at athlete, and athlete, because of this is the parts of the jump electric from takeoff, and this is the landing. This is the landing place here, right? And the distance given by the question here is 9.12 meter, right? And the angle here is 25, right? So this is the if you draw the situation from the information given by the question number 10a. So number one is the calculate initial takeoff. So here is the initial takeoff. What is the initial u here? If you start with the let's say the objects, this is the maximum height, this is h. At the position at the maximum h, the maximum height, so v or vy is equal to 0. So here you can to find the u here, first you can refer to the equation vy is equal to uy minus gt. Okay, so because the we use the equation here because we want to find the value of time of flight from the this is the time taken for the object from the ground surface to the maximum height. So and the final velocity here is equal to 0, and this is a uy. Let's say here this is theta, so here uy, here you resolve u here to the, this is ux, this is ux, and here we have a this uy. So we have considered a uy here because uy opposite 25 degrees, so we have a u y sine 25, right? So 25 minus this is g is 9.81 t, right? So now here, okay, I think no need for we use the value of uy here. Okay, let's say we have a use a theta. Okay, still use a uy sine theta first, right? Sine theta first is equal to minus gt. Okay, and this is equal to 0, so here t is equal to uy sine theta divided by g. The value of t here, okay, we find the value of time of flight here. Let's say with time of flight, not the time from the ground level to the high, the maximum height h. Okay, we find the t for the time of flight here, meaning the vy is equal to okay, let's say this is the t time taken for from half, okay, from ground to the maximum height, and the t, let's say this is first part t1 and the second part t2 from maximum to the ground. Okay, but the t1, if you calculate the total t here is total, meaning t1 plus t2. So here we have a time 2, right? This is 2t here, this is time 2, right? Or you can use a t here is equal to 2uy sine theta divided by g, right? Okay, next is, if you can let's say we find this is r, right? This is r is equal to range 9.12. So to find the value of the k r, right? Distance is equal to u or velocity times t, right? This is the range, but this r is on the x-axis, so here we have a ux. So now here we have a r here. For the u resolve to the ux here is a u, right here, u cos theta, and time t. Time t is time of flight here. Okay, so you can refer to the t here, right? So right here, okay, right, this number 1, right? Okay, continue now to find the value of the r here. R here is equal to, sorry, r is equal to u cos theta t. T here is this is t. Is equal to 2uy, 2uy. This is a u x here, right? Sine theta divided by g, right? So our next is, so we have a r here. Okay, you can have a final here. We have a u squared divided by g. This is 2 u. Can use a 2 sine theta cos theta, right? Okay, or I can write the equation here. Sorry, this is the final equation. Actually, this is the final equation that you can use to find the value of the u here, right? Because in the lecture note, this is the final equation or a formula. Okay, you can use to calculate the value of the u, because r is a range given by the question is 9.12 and the g is 9.1 and the theta here is a 25 degrees. So you can find the value of the u. So you can use the calculator and put in all the value to the formula equation here, so you can find the value of the u. So the final answer for the u you can calculate is u is equal to, okay, I write here, ku is equal to 10.8 meter per second, right? So this is the final answer for number 10A, right? As I said, so in the exam, if the formula or the list of formula given by the question, you can just use the straightforward to the equation here. But this is how we can find the equation here. R is equal to u squared times 2 sine theta cos theta divided by g. Right? From the equation here or formula, you can find the value of the u or initial takeoff speed. Right? Continue to question number 2. Calculate the maximum height of jump. Alright, so I think the same process here. The question to ask you, so this is the object and this is the theta 25 degree and this is the u and this is the parts of the motion of the object in the projectile motion, and this is the maximum height of the object or jump. Okay, jump athlete. Here is a maximum height. So now the question asks you what is the value of the h. Actually, you have the same process for question number 1. You have the final equation that you can use. H is equal to u squared sine square theta divided by 2g, meaning that straightforward you can find the value of the u, so u here, you can use value from the answer number 1, and the theta is 25 and the g is constant, and you can find the maximum high. Okay, but how you can get the formula here if the question will give you the final equation, the formula? So you can start from the equation v, this is referred to the vertical, v square uy square divided time 2g s or h, okay, this displacement. So now to calculate the h here, the h the maximum, right? The maximum h here, right? The maximum. So okay, first is what is the value of the vy square at the maximum? At the maximum, right here. So the value of the final the value of the vertical direction of the object vy is equal to 0. So you have a uy. You can resolve u to the y axis here. This is a uy. So here we have a uy sine theta, right? Minus 2g x max. So now you can, sorry, this is square, right? This is square and this is square. So now you can use to calculate the h maximum is equal to, okay, u y square sine theta square and divided by 2g. If you compare the equation here, right, so we have the same look like the equation here. Okay, this is u square, and this is sine theta square divided by 2g. So you can use the equation here to find the value of the maximum height, because uy square, initial u, right, sorry, this uy here is an initial u here is answer number A, number 1, and the sine theta is 25 and g is a constant 9.81. So you can find the value of the maximum h, or maximum height, h maximum is equal to 1.06 meter, right? Okay, so we go to the next question. Suggest the two-way to increase jumping distance. So meaning here you have this is 25 degree and this is u, and this is angle y and x, right? So as we discussed earlier, so this is the distance or range r. So increase the jumping distance here. This is how you can increase the value of the r. How you can increase the value of r, or range distance, right? Sorry, range distance. And for the equation, equation number number 2, so you can use the sorry, this is number 2. This is maximum height. Now we use the equation that you can find the value of the takeoff or speed. Start from the, not the value of h, you can use the range is equal to u square sine 2 theta divided by g. So the equation here is how you can find the value of the takeoff speed. So you can back to the answer number 1. So you have an equation here. So now this is how you can increase the value of r, range, right? So to increase the value of r, because g is constant, gravity, right? So you cannot increase or decrease or change the value of g. Also we have a sine 2 theta here. So now we have a theta and u. Okay, first you can increase the value of r, you can increase the initial u. And number 2, you can increase the value of the sine theta here. But the maximum theta or maximum the value of sine, because sine theta sine 90 is a maximum. So here to find the value of the sine theta 90 here, because this is time 2, so here theta must have a half of 90 is a 45 degrees. So you can use the theta 45 degree and use the increase the value of initial u, that you can increase the value of the range r. So that's all. Thank you. See you on the next video.